Welcome to the answers to the monthly test on the topics application of derivatives and integration, conducted at KENDRIYA VIDYALAYA, ASHOK NAGAR, CHENNAI. Question number 1. The side of an equilateral triangle is increasing at the rate of 2 cm per second. At what rate is its area increasing when the side of the triangle is 20 cm? This is a problem under application of derivative, that is rate of change of quantities. Let us call x as the side of the equilateral triangle and AB the area. And what is given, let us write first. The rate of increase of the side is given, therefore dx by dt is given as 2. Now we know the formula for area, it is root 3 by 4 x square. Therefore dA by dt, if you differentiate, root 3 by 4 constant, x square differentiation, 2x into dx by dt. Now I substitute dx by dt given in the question. It will become dA by dt is equal to root 3x. This is a general formula for the rate of change of area. Now they want the rate of change of area when the side is 20, that is x is 20. When you put x is equal to 20, you will get 20 root 3. Therefore, area of a triangle is increasing because you are getting plus 20 root 3, therefore increasing at the rate of 20 root 3 centimeter square per second. Question number 2, integration. Dx upon cos square x by 1 minus tan x the whole square. Now this cos square x can be written as 1 by cos square x can be written as secant square x. Now by visualizing this integral, I am seeing that the differentiation of tan x is in the numerator. Therefore I take u as tan x, du as secant square x dx. Now let us do the substitutions now. For secant square x dx I have to put du, and for tan x I have to put u, therefore 1 minus u the whole square. Now you are having a linear factor the whole square in the denominator, that can be written as 1 minus u whole power minus 2 by making use of the formula 1 minus u whole power minus 2 plus 1 by minus 2 plus 1. Here you should be very careful, the coefficient of u is minus 1, that should be put in the denominator. Therefore final answer 1 upon 1 minus u. Now what is the procedure for substitution problem? Do the substitution, do the integration, then after that do the resubstitution. When I do the resubstitution, it is 1 upon 1 minus tan x plus c. Question number 3. Evaluate 2 upon 1 plus cos 2x, and by making use of the multiple angle formula which you already studied, this 1 plus cos 2x can be replaced by 2 cos square x. The formula obtained from cos 2x is 2 cos square x minus 1. Therefore 1 plus cos 2x is 2 cos square x. 2 getting cancelled. We are getting secant square x. Therefore tan x plus c is the answer. You are getting a direct formula. Formula number 4. Evaluate secant square x by root tan square x plus 4 into dx. Here by visualizing the integral, the differentiation of tan x is inside. I take u as tan x, du as secant square x dx, or I get secant square x by root tan square x plus 4. When I do the substitution, it is du upon square root of u square plus 4. Here all of you are having some confusion. You are thinking that it is square root of something, therefore whole power 1 by 2, therefore whole power minus 1 by 2, and we are doing it. Be careful. Inside the square root, you are having a quadratic factor. Therefore, it should be written as u square plus 2 square. The formula is log of x plus that square root. Root a square plus x square dx upon is log of x plus that square root. Therefore log of u plus root u square plus 4. As usual, substitution, integration, resubstitution for log of tan x plus square root of tan square x plus 4 plus c. Now another question, show that the function is strictly increasing. Whenever they ask you to show that it is increasing, prove that its derivative is greater than 0. They ask you to prove that it is decreasing, prove that f dash of x is less than 0. These types of problem, when it come for 1 mark or 2 mark, you have to do it directly. Don't try to use the derivative test and make the problem a bigger one. Now let us go for f dash of x now. A function is strictly increasing if f dash of x is greater than 0. Therefore f dash of x is 3x square minus 6x plus c. I take 3 outside, it is x square minus 2x plus 2. Now remember, this is not a perfect square, that is, it is not a minus b whole square form, and you cannot factorize it also because b square minus 4 is less than 0. But we have to prove that this x square minus 2x plus 2 is always greater than 0. Further, let us do like this. X square minus 2x can be written as x minus 1 the whole square minus 1 plus 2. You are seeing over here, it is x minus 1 the whole square plus 1. Therefore, x minus 1 whole square is always greater than 0, plus 1, therefore it is totally greater than 0. Therefore, f dash of x is greater than 0 for the function is strictly increasing. Now you are seeing the graph of it, it is going up, therefore this function is a increasing function. Now another problem is on the marginal increase. The marginal, whenever the word comes, you have to find the derivative. For I am finding the derivative, marginal increase is d by dx of p of x. I have done it. 3x square and 2x are the derivatives, and derivative of 30x is 30. Now they want, when the 3 diesel vehicle are added, they want it at x is equal to 3. For I am putting x is equal to 3, I am doing the calculations, and it is coming as 30.1335. Whenever you are finding it that marginal increase and all, you have to find the first derivative. Question number 7. Evaluate integral secant square x by cosecant square x dx. Whenever you are having any problem of integration of trigonometric functions, better try to convert them into basic trigonometric functions. I am converting. Secant square is 1 by cos square, 1 by cosecant square is sin square. I am getting tan square. It is secant square x minus 1. The integration of secant square x is tan x. Integration of dx is x. Therefore, the answer is tan x minus x plus c. Now, whenever they are asking you maximum and minimum value of a function, that can be done by derivatives also, but this is a modulus function. Therefore, we have to check the nature of the modulus function, and then we have to identify what will be its maximum and minimum value. For that, I am taking f of x. All of you know what is the nature of mod x plus 1. It is always greater than or equal to 0. Now, you have been given minus mod x plus 1, but when you do it, it will become less than or equal to 0. When I add 7 on both the sides of the inequality, minus mod x plus 1 plus 7 is less than or equal to 7. What is the meaning of less than or equal to 7? You can have at most 7. Therefore, the maximum value is obtained when this x plus 1 is 0. Therefore, maximum value is 7. But the minimum value you are not able to tell. Therefore, the minimum value is not there. No minimum value. It is going to minus infinity. Therefore, there is no minimum value. For maximum value is 7, minimum value is not possible. Now, whenever these types of problems are coming, don't try to use derivative test and all, because it is a modulus function. By making use of the property of modulus function, you are identifying the maximum and minimum value. Let us try to see the graph of it. This is a graph. You are seeing that this is a V-shaped curve, the inverted one, where the maximum value is coming as 7 on the y-axis, 7 at obtained at minus 1, but minimum value is not there because it is going down, down, down. Therefore, there is no minimum value. Now, another problem, prove that it is strictly decreasing. You have to check whether the first derivative is less than 0 in that interval. Now, a function is strictly decreasing if f dash of x is less than 0. I am doing derivative tan inverse of something, 1 by that function whole square into differentiation of that function. And differentiation of sin x plus cos x is cos x minus sin x by the denominator. But you are seeing here, the denominator is a perfect square, that is whole square. No need to worry about it. We have to check what is the nature of the numerator. If the numerator is positive, f dash of x is positive. If the numerator is negative, f dash of x will be negative. But we are seeing that in the interval pi by 4 to pi by 2, cos x is less than sin x. Whenever you are seeing that value of cos x and sin x, what is sin 30, what is cos 30, like that, when you see, then cos x will be less than sin x. For cos x minus sin x will be less than 0. For numerator is negative, denominator is already positive. Therefore, f dash of x is less than 0. What will happen when f dash of x is less than 0 in an interval? The function is strictly decreasing. Let us try to see the graph of it. It is a graph. The total graph I am showing you for tan inverse sin x plus cos x. But a part of it, that is pi by 4 to pi by 2, you are seeing that the graph is going down. Therefore, it is strictly decreasing. Go to the next question. Cos 2x by sin x plus cos x the whole square dx. This can be done in two ways. Cos 2x can be written as cos square x minus sin square, and you can cancel with the denominator. Otherwise, what you can do, you can expand the denominator. It is sin square plus cos square plus 2 sin x cos x. It is of the form 1 because sin square x plus cos square x 1. 2 sin x cos x is sin 2x. Now you are visualizing here that numerator contains the differentiation of sin 2x, where I am taking u as sin 2x. du as cos 2x into differentiation of 2x is 2. But I am having only cos 2x dx in the numerator, where it is half du. Don't forget that constant. For I am substituting half du by 1 plus u. Now half into du upon 1 plus u. It is log of 1 plus u. The coefficient of u is 1, therefore no need to worry about it. Now what is the procedure? Substitute, integrate, resubstitute. Therefore the answer is half of log 1 plus sin 2x plus c. Question number 11. 1 upon 2x square plus 4x minus 3. It is a type where it is a problem of integration. Denominator you are having a linear quadratic factor. First step number 1, you have to take 2 outside because the coefficient of x square should be made as 1. Now you have to take x square plus 2x, write it as x plus 1 the whole square minus 1. Put it inside the integral sign. It is x plus 1 the whole square minus 1 minus 3 by 2. Be careful with the constants because the constants are going to decide the nature of the formula. For the constant is minus 5 by 2. You have to visualize it as x square minus a square. For x plus 1 the whole square minus root 5 by root 2 the whole square, or square root of 5 by 2 the whole square. Now the formula is 1 by 2a log x minus a by x plus a. In place of x you are having x plus 1. In place of a you are having root 5 by root 2. I have done it. Can be kept as it is, but it can be simplified by making use of taking LCM and all. Final answer 1 by 2 into root 2 by root 5 into log of root 2x plus root 2 minus root 5 upon root 2x plus root 2 plus root 5 by taking the LCM in the denominator. Let us go to question number 12. This is a problem on integration of trigonometric function. Now it is a product of two trigonometric function. Now we have to make use of the formula how to convert the product into sum. For that we are having a formula 2 sin x sin y is equal to cos of x minus y minus cos x plus y. Cos of difference minus cos of sum. But 2 is not there. Multiply and divide by 2. Now you get cos of x minus y, that is 7x minus x, minus cos x plus y, that is 7x plus x. You got cos 6x minus half into cos 8x. Direct integration. Cos 6x integration is sin 6x by 6. Cos 8x integration is sin 8x by 8. Very simple problem, direct problem. But remember, whenever problem like this comes, product of trigonometric functions are given. Make use of that expressing product as some formula. Once again, this is a problem where we have to prove that the function is increasing in an interval, decreasing in an interval. All of you know, to prove that increasing, first derivative greater than 0. Prove that decreasing, first derivative less than 0. Let us check. This is f of x log sin x. Do the integration. So differentiation. F dash of x is log of sin x is 1 by sin x into differentiation of sin x is cos. Therefore it is cot. But now what is the nature of cot x? 0 to pi by 2 is first quadrant. Therefore cot x is greater than 0. Therefore f dash of x is greater than 0. Therefore it is increasing. Go back to the second given interval given there. Pi by 2 pi. Therefore this is the second quadrant. Cot x is negative. At here f dash of x is less than 0. Therefore it is strictly decreasing. Now you can take some value between pi by 2 and pi also you can check. But in this problem the given intervals are very clear that first quadrant and second quadrant, but directly you can make use of the property of the trigonometric function there. Now this is the graph you are seeing over there, that log of sin x graph from 0 to pi by 2 it is going up, from pi by 2 to pi it is coming down for increasing and decreasing. Now let us go to the problem of sin power 4x dx. Now sin power 4, cos power 4, all of them, the procedure is very simple. We are going to reduce this by making use of the formula that sin square x the whole square I am writing. Whenever you are getting sin square x, it should be written as 1 minus cos 2x by 2. Remember, for cos square x it is 1 plus cos 2x by 2. For sin square x it is 1 minus cos 2x by 2. For 1 minus cos 2x by 2 the whole square, expand it. It will be 1 by 4 comes out. A minus b whole square formula 1 minus 2 cos 2x plus cos square 2x. But once again that expanding it as 1 by 4 into dx minus 1 by 4 into 2 cos 2x plus 1 by 4 into cos square 2x. Let us continue. Now again, first two integrals are now no problem, directly you can do. Again, that cos square 2x to be written as 1 plus cos 4x by 2. Be careful, it is 2x, therefore twice that 2x is 4x. Now split the integral now. First integral 1 by 4 dx, second integral 1 by 2 cos 2x, third integral 1 by 8 x and 1 by 8 into sin 4x by 4. Very simple. Now you can club that 1 by 4x and 1 by 8x and you can write it as 3 by 8x. Now it's a problem where power of sine is 4. We are reducing it by making use of the formula cos square x is 1 plus cos 2x by 2, sin square x is 1 minus cos 2x by 2. Go to question number 15. We have to find the interval in which the given function is increasing and decreasing. And we have to make use of derivative test. Take f of x, differentiate it. Product of two function, keep x square, differentiate e power minus x, plus keep e power minus x and differentiate x square. Be careful. UV formula you have to apply. When I do it, it is minus x square e power minus x plus 2x into e power minus x. When I want to equate it to 0, I will take something common. Which is common now? X into e power minus x is common. When I take it out, it becoming as 2 minus x is equal to 0. Now, whenever you are equating a product of three terms to 0, I think all of them are 0 or only some of them are 0. Here, e power minus x cannot be 0. Therefore, x is 0 and 2 minus x is 0. Therefore, x is equal to 2. Therefore, these are the critical points. Now, the point 0 and 2 divide the real line into three disjoint intervals. How they divide? Like this they divide. Minus infinity to 0, 0 to 2 and 2 to infinity, all open intervals. Your job is very simple now. You have to check the nature of f dash of x at these intervals. That is minus infinity to 0, 0 to 2 and 2 to infinity. Let us do it now. Minus infinity to 0, let us take one convenient value. I am taking minus 1. I am finding what is f dash of minus 1. Very simple, you have to check whether it is a negative or positive, but e power something cannot be negative. Be careful in that. Therefore, at x is equal to minus 1, I am getting less than 0. Therefore, it is decreasing. Minus 1 into 2 plus 1, therefore, negative. Therefore, if you consider 0 to 2, I take 1, the same thing. I am getting greater than 0. E power something cannot be negative. Remember that. Therefore, it is decided only by the first term and the last term. Good. Therefore, it is increasing as f dash of x is greater than 0. Let us go to the next one. 2 to infinity, I take 3. The same thing, 3 into minus 1, therefore less than 0. So it is decreasing. For when I put it as a nutshell, f of x is decreasing in the first interval, increasing in the second interval and decreasing in the third interval. Let us see it in the graph now. You are seeing this function x square into e power minus x. From minus infinity to 0 it is coming down. From 0 to 2 it is going up. From 2 to infinity once again it is going down. Now question number 16, again problem from rate of change of quantities. Surface area is given, rate at which the volume of the bubble is increasing at the radius is 6 cm. Whenever rate of change of surface area is given, rate of change of volume will be asked. When rate of change of volume is given, rate of change of surface area will be asked. Let us take r as the radius and s as the surface area, and ds by dt is equal to 2 cm square per second. Therefore, surface area is s is equal to 4 pi r square. For when you differentiate it, ds by dt is equal to 4 pi into 2r into dr by dt. ds by dt is given as 2. Therefore, dr by dt I obtained as 2 by 8 pi r or 1 by 4 pi r. But don't put 6 over here because this dr by dt is a general formula for rate of change of radius at any point. Well, now let us go to v as the volume. The volume at any time is v is equal to pi r cube. For dv by dt I am finding. Therefore, dv by dt is equal to r I am getting by cancelling. Therefore, they want when r is equal to 6, what is dv by dt? It is only 6, but it is 6 centimeter cube per second. Simple. Let us go to the next evaluation. That is integral of 6x square plus 1 by 4x cube plus 2x minus 5 the whole cube. Whenever this whole cube problem comes, don't try to do it by integration by partial fraction or integrate. Okay, cannot be done because the whole cube is there in the denominator. But the numerator may be the differentiation of the term inside the bracket. Let us check. I will take u as 4x cube plus 2x minus 5 and I am getting du as 12x square plus 2. I can take 2 outside, it will become 6x square plus 1 into dx. You are seeing 6x square plus 1 is there in the numerator. Therefore 6x square plus 1 into dx is half into du. Put it there inside the integral sign now. Half into du by u cube. Half comes out u power minus 3, u power minus 2 by minus 2. Minus 3 plus 1 by minus 3 plus 1. Therefore it is minus 1 by 4 into 1 by u square. Now all of you know what should be done. Resubstitution. I have done the resubstitution. I got that. Simple. Good. Let us go to question number 17. You evaluate x square plus 1 by x plus 1 the whole square. This problem can be tried by putting u is equal to x plus 1. Therefore u is equal to x plus 1, x will be u minus 1, du will be dx. Put it there inside the integral sign now. For x square I have to put u minus 1 whole square. For x plus 1 the whole square I got to put u square. And numerator is u square minus 2u plus 1 plus 1. Numerator is becoming u square minus 2u plus 2 by u square. Then split the integral. U square by u square is 1. Minus 2u by u square is minus 2 by u plus 2 by u square. Now do the difference integration directly. Integration of 1 is u. Integration of 2 by u is log u. Integration of 2 by u square is minus 2 by u. Do the resubstitution. Problem over. Now this problem, so many ways you can do. You can try to cancel the denominator with the numerator. X square plus 1 can be written as x plus 1 by 2 the whole square like that. Okay, anyway. Now this is the easiest method. By doing substitution we are trying to get the numerator cancelled with the denominator. Question number 18. You have to find the absolute maximum and absolute minimum value for a function in the given interval. What is the procedure? You have to obtain the critical point plus the endpoints you have to take of the interval and check the value of f of x at this point. Maximum is the maximum, minimum is the minimum. Well, f of x is given, f dash of x I am finding. Very simple. When I equate it to 0, I am getting x is equal to 1. But this x is equal to 1 is one of the extreme points of the interval, where I have to take only x is equal to 1 and the end points also I have to take. For I have to take the points minus 3 and 1. Find f of minus 3, it is 19. Find f of 1, it is 3. Therefore maximum value is 19 attained at minus 3. Minimum value is 3 attained at x is equal to 1. Let us see the graph of it. This is the graph. You are seeing x minus 1 the whole square plus 3. I have taken only a part of the graph from minus 3 to 1. The maximum value is 19 shown in the graph. Minimum value is at the down 3 shown in the graph. Find two positive numbers whose sum is 60 and product of the squares of the number is maximum. Be careful, product of the squares of the numbers. You have to take the number as x and 60 minus x because sum is 60. Find the product. And I am doing the differentiation. Keep the first, differentiate the second. Keep the second, differentiate the first. I am simplifying it. It is minus 2x square into 60 minus x plus 2x into 60 minus x the whole square. I have to equate it to 0. When I equate it to 0, I have to take 2x into 60 minus x outside. I am getting 2x into 60 minus x into 60 minus 2x is equal to 0. And when you equate it to 0, x is 0, 60 minus x is 0 and 60 minus 2x is equal to 0. But 60 minus x cannot be 0. Therefore, only 60 minus 2x is equal to 0, x is equal to 30. Out of these three brackets, x is cannot be 0 and 60 minus x cannot be 0. Therefore, x is 30. Now I am finding the second derivative. Once again, keeping the first, differentiating the second like that. And at x is equal to 30, I am finding by putting the value, I am getting negative. No need to evaluate it totally. By simply seeing it, I am getting both the terms are negative, therefore less than 0. Therefore, product is maximum and x is equal to 30. Therefore, numbers are 30 and 30. Now, next problem is a problem of application. Cylindrical vessel has the least surface area when the height is twice. Given volume means volume is constant. Therefore, r is the radius and h is the height. Volume is, formula is pi r square h. From this, I am getting the formula for h in terms of r. H is equal to v upon pi r square. Keep it ready. Put it in the formula for surface area. Therefore, surface area is 2 pi r into v by pi r square plus 2 pi r square. What is the nature here? We are expressing surface area in terms of a single variable. Therefore, S is equal to 2v by r plus 2 pi r square. Now, let us find with respect to r now. 2v into differentiation of 1 by r is minus 1 by r square r square differentiation is 2r. Normal differentiation, but I have simplified it. Now I continue. Now I have to differentiate it once again. I am getting 4b by r cube plus 4 pi. Let us keep it ready. Now I have to equate ds by dr is equal to 0. First derivative as 0. From here, when I make use of the equation, 2b by r square is 4 pi r. When I do the cross multiplication, 2b is equal to 4 pi r cube. Therefore, r cube is equal to 2b by 4 pi. Or you can write r is equal to 2 cube root of 2b by 4 pi. But I am getting r cube as v upon 2 pi. For when ds by dr is equal to 0, r cube is v upon 2 pi. I am keeping it ready. Now I have to put this value in the second derivative and check whether it is greater than 0 or less than 0. When I put it, no need to do any simplification. First term is positive, second term is positive. Therefore, total is 0. Therefore, when r cube is this, the surface area is minimum. Second derivative test is greater than 0. Therefore, it is minimum. For what will happen when r cube is v by 2r? V is pi r square h by 2 pi. When I do the cross cancellation, I am getting 2r is equal to h, which means that height is twice the radius. Therefore, for the cylinder of given volume, when the surface area is minimum, height is twice the radius. We will go to question number 20. Find the maximum minimum value of the function at 0, less than x or equal to x, less than or equal to pi by 2. What is the procedure? Find the first derivative, equate it to 0, get the critical point, and take the critical point plus the point of end points of the given interval. Find the value of f of x at those points. Maximum is maximum, minimum is minimum. Let us take f of x, differentiate. Cos 2x differentiation is minus 2x into 2. I am getting cos x minus sin 2x. I have to equate it to 0. For that, let me write sin 2x as minus 2 sin x cos x. I have to take cos x outside. It will be 1 minus 2 sin x. I have kept it ready for equate it to 0. When I equate it to 0, cos x is 0 and 1 minus 2 sin x is 0. What will happen when cos x is 0? X will be pi by 2, and when 1 minus 2 sin x is 0, 2 sin x is 1, sin 2x is half, for x is equal to pi by 6. Therefore, when you equate this f dash of x is equal to 0, you are getting the values of x as pi by 2 and pi by 6. Now this is f of x. Let us find the points pi by 6, 0 and pi by 2. Find f of 0. It is half. Find f of pi by 6. It is, be careful here, it is cos 2x. Therefore, when x is pi by 6, cos 2x will be cos pi by 3. Therefore, the answer is 3 by 4. When I put pi by 2, x is equal to pi by 2, I am getting the answer as 1 by 2. Now you are visualizing it as 3 by 4 is the maximum value and 1 by 2 is the minimum value. Therefore, maximum value is 3 by 4 obtained at x is equal to pi by 6. Minimum value is 1 by 2 obtained at 0 and pi by 2. Let us see the graph. This is the graph of the function. F of x, you are seeing that from 0 to pi by 2 when you visualize it, 1 by 2 is the minimum value and 1 by 2 is the minimum value attained at 0 and pi by 2. 3 by 4 is the maximum value attained at x is equal to pi by 6. Well, thank you.